Yes, hello friends. So this is the video tutorial for today's Leetcode problem today, 756, which is pyramid transition matrix. So yeah, let me go give you an overview of the question because the question is very big and reading it will take a lot of time. So basically, you're given two variables. One is this bottom, which is a string. This string is basically the bottom layer of the pyramid. So we can see BCD. So the bottom layer of the pyramid is BCD. We are also given the vector of strings called allowed. Now each of these allowed string is of size 3, which basically represents that if my left corner is B and my right corner is C, then on top of it, what value can I put? So here BCC basically means that if the left is B, right is C, then on top of it, I can put C. Similarly here, so we have CDE. So left C or D right on right. On top of it, I can put E because to form a pyramid, this has to be of size 3. This has to be of 1 minus 1 size of the previous, so 3 minus 2. And similarly, the 3 minus 1, that is 2. And here also 2 minus 1, size 1, right? Which makes sense. Similarly, here we are given CEA. So on top of C and E, we can put A. Also, we are given FFF. So, but there is no F here, right? So this makes sense. What are these two variables, allowed and bottom? What we need to find is that can we form a pyramid such that each of these on top of each value only allowed values are put. So like on top of B and C, here we can only put C, right? If we are putting D, then this is called an invalid pyramid, right? And yeah, that is what we are asked. The constraints are very important here, that we know that yeah, what we know is that bottom start length, that is the size of the bottom most layer, would be of size at max 6, and also only the values from A to F are given in this array, or are allowed basically. So okay, how can we solve this question? So we know what these allowed values are, right? Okay, so we know what the allowed values are. Let's say if we know the bottom layer, can we calculate what are all the top values on it? Right? If we know the bottom layer, can we calculate what are all the top values on it? What can this be? See, if let's say the allowed values for BC, so BC basically meaning B on the left, C on the right, what are all the allowed values for it? Let's say this was something like A, B, E, right? And so similarly for CD, we had E and F, something like this, right? I'm not taking this exact case, but yeah, so what are the values that could on top of it? For BC, these three values could be put. So here it could be A, let's say. For CD, it could be EF. So AE, right? So AE could be 1, then it could be BE, then it could be also EE on all of these values, right? Okay, that is fine. So can I say that if I know my bottom layer, I can get the all the values of the on top of it. Then if I know this layer, then all the values on top of it, right? So one thing is clear from this, that if I know my layer, let's say this is layer I, then I can, or let's make it like this is layer of length n, and this is layer of length n minus 1, right? Because the size decreases by 1. This is length of n minus 2 layer. Okay, so one thing is clear here, that layer n minus 1 or will only depend on layer n, or I can generalize this, that layer I would only depend on its previous layer, right? I plus 1, because it is obvious that if I know all of these values, then I can calculate all the values on top of it using my allowed structure. Okay, so this is one thing should come to your mind immediately after reading and understanding the question. The other thing is, what is the amount of unique values a layer could have? That each layer, what is the number of values that it could have? See, I know that my n, the size of my bottom, is of size 6, right? So n is at most 6, and the allowed values are A to F only. A to F is A, B, C, D, E, F. So this is also 6, right? So let's say if n is 6, then the each layer, let's say the size is 6, so it could have 6 raised to a 6. If the size is 5, it could be 6 raised to a 5. You see, there are n slots, and each slot has 6 choices. So it becomes 6 in basically the allowed choices into the size of it, right? So if it is 6, then it would have 6 raised to a 6. Then this would be 6 raised to a 5. This would be 6. So this is for 5 size, this is for 4 size, this is for 3 size, this is for two size, this is for one size, right? So these are all the possible states that or possible layer values that could be. Is this value very big? I don't think so, because I think at max this value could be like 2 raised to power 6 into 6, and 6 raised to power 6 is very small, right? 6 raised to power 6 is very small. So how can this be helpful is, see, this is a recursive question, right? So I will create a recursive function which takes a parameter string previous. Previous basically meaning the layer before it, right? Now for this previous, I will get all my current choices. So I will get a vector of string choices using some function and passing it previous, because I know that with this previous I can get these many strings. Now for each of the string, so for each of this string that is in the choices, I will make a choice on it. So if recur choices, so recur is, sorry, I am choosing this string. If this is true, I will return true. Else, if none of these strings returns true, I will just return false, which makes sense, right? Basically, for this string, I get all the choices. I put all the choices at the current layer that we are currently on. And if none of these result return in false, return true, then basically the parameter is invalid. So I should return false. If any of them return true, I will return true. And what would be a base case here? A base case would be that if previous dot size is 1, because now we have to put a size equals to 1. So basically we have come to this state A, B, C, D, E, B, right? This kind of grid. So now basically we are creating a string of 0 size, and that is fine, right? If we come to this is the base case that we are considering on. So what I was saying is that this previous, the number of unique values would be 6 raised to power 6, of the order 6 raised to power 6. If I know that the number of total values that this previous could be this only, then I should not actually do this. I should use DP or memoization here. Memo here. So I will create a map on the string, and basically if this already has been looked up, I will look it up again. And see, if you can ask me, okay, I don't think there would be overlapping subproblems, because why we use memoization is basically we have calculated a subproblem again, and now we are seeing a subproblem again. And in this case, identifying that there is overlapping subproblems is a bit trickier, but I like a hack you can do is just calculate the number of total states. If that number of total states is very less, use memoization. In the worst case is what you are creating a DB array and there's no use of it, but in the best case it will reduce the time complexity. So basically calculate the number of states. If number of states is very less, then let's use memoization. If it is very large, then creating that DP array would really in itself. But yeah, let me okay, yeah. So let me show you why there are overlapping subproblems. So let's say my bottom is A, B, C, right? And for A, B, I can put C, D, and for B, let's make it A, B, C, D. For B, C, I can again put C. Okay. So let's say for A, B, I can put C, right? So I put C here. Then for B, C, let's say I can put E, right? So let me put E. For CD, let's say I can put A, B. So let's say I put A here, right? Now for CE, let's say I can put A, and for EA, I can put B, right? So I get this state, right? Now, if I make a different choice, so for a different choice on this, let's say for BC, okay, so BC, we only allowed it. For CD, let's say I can also put E here, right? So for CD, let's say I also put E here, and for EE, let's say I also allow B here, right? So again, this would be this state would again come AB. So I'm again basically calling my recursive on this string, and that is why we are getting a overlapping subproblem. I think you were able to understand this, right? So hope I have given you a good idea. You should try to implement this code on your own now. If you are still facing issue, I will show you my code. So yeah, I think this is someone else's code. Yeah, this is my code. So yeah. Uh, so basically, first of all, I create this allowed characters. This allowed characters would be a vector of vector string, basically allowing me to know if my left is there and my right I know, then what are all the allowed characters. So basically, I go over all the allowed strings in this. I calculate A as S0 minus A and B as S1 minus A, basically mapping each of this. So what I'm trying to do is, see, for is creating this vector of the form in a vector of vector string, because storing this in a map would add additional lookup. So A and B would basically become this 0 B 1. So in 0 comma 1, this is a 2D matrix. I will store all the allowed string of all the allowed characters. So like this 0 1 would be CD, this would be 1 2, and this would only have one character E, right? So we are storing this in this 2D string 2D string array, right? So I cal in allowed characters A to B. So left is A, right is B. I allow this character S to do. Basically, this character could go on top of A and B, right? So I push this back, and then I do not need to use this. I just call my recur function on my bottom, right? So yeah, as we discussed that if previous dot size is 1, then this is the base case. We'll just return true. Else we'll see if this is has already been calculated. So I will look this up in my DP map. So why we are using a map here is is because we have to look upon strings, right? So looking upon strings is easier on map than converting it into an integer and then looking up into a vector. So yeah, that would have been a trickier implementation. But yeah, I like to use map, not an ordered map, because an ordered map does not guarantee your time complexity, and in most competitive programming contests, it can lead to TLE, even though your asymptotic time complexity is less. So yeah, I just like to use map. It's up to you. In Leetcode, it doesn't really matter. I think in most contests, you using an ordered map would actually reduce your time complexity and reduce the time taken by your code. So that's fine. So I just look up this into my DP if this has already been calculated. Then I calculated all my choices that I can put using the previous. So if the previous choice is this, then what are all the choices I can make? And for all the choices, I call my recur function and store this. If any of this return true, I will return true and store it into my DP map. Else I will just return false and again store it into my DP map. Now the only thing is, how do I get this get choices, which is a pretty like backtracking code, right? So you should go over all the. So yeah, what we do in this get choices is basically maintain the index that we are currently on, or the index of the current string that we have to on. So if this a previous strings index that we are currently on, right? So if BCD is there, so how will you get all this vectors of string that we can allow is basically first let's put our index here. So left is this, right is this. Get all the characters that can be there with left B and right C. How we can do this is basically look up into our allowed characters 1 comma 2, and for all of them, let's say this all into 2 was uh, something like EF, right? If this was E and F, then we'll first put E, then call a recur function on this, then make all the choices, and then backtrack and then put F, right? This is a pretty this is a simple backtracking thing, right? So I calculate my left, I calculate my right, and I go over all the characters that I can put. I make that choice. I again get choices on I plus 1, and then I remove it from the current thing, right? And in base cases, what would be a base case is that we have come to this index, because this index does not have a right neighbor, so there would be no character that we will put in current cur, right? So if this is a base case, then we'll just put it into the choices, right? So this works. Thank you for watching. If you were able to understand anything, give me a like and subscribe, all of those things. Bye. Let me just show you that. Yeah, bye.